This video provides a summary of the procedures used for testing the compressive strength of 6-inch by 12-inch concrete cylinder specimens. This procedure is identical to that for the 4-inch by 8-inch compressive strength test seen in a previous video, with the exception of specimen geometry. When performing compressive strength testing, the following safety precautions are required: safety glasses, closed-toed shoes, and a hard hat. Additionally, it should be mentioned that at no time should the safety cage around the apparatus be opened while the machine is running. The following equipment, materials, and supplies are required for compressive strength testing: a 6-inch by 12-inch hardened Portland cement concrete cylinder, 6-inch diameter end caps, a testing machine capable of applying a controlled rate of loading, a system capable of measuring and recording the ultimate load applied to the specimen. With the machine off, place the 6-inch diameter bottom end cap into the device and carefully center it below the loading head. Next, place the 6-inch diameter concrete cylinder onto the end cap. Place the top end cap onto the concrete cylinder. Verify that the specimen is aligned with the loading head and then close the door to the safety cage, securing it with the pin. The TA will ask you to compute the proper loading rate in pounds per second that the machine will have to apply in order to achieve the specified loading rate in terms of PSI per second. This is accomplished using the same procedures as was used to calculate the loading rate for the 4-inch by 8-inch specimens, the difference being the larger cross-sectional area of the 6-inch by 12-inch specimen. Due to the larger cross-sectional area of the 6-inch by 12-inch cylinders, a higher loading rate is required to achieve the same target of 35 psi per second. The TA will input the calculated loading rate into the testing software and then begin the test. Similar to the test conducted with the 4-inch by 8-inch specimens, you will see an increase in load up until the point of failure, at which time the load will begin to decrease. The concrete strength is calculated by taking the peak load obtained and then dividing this by the specimen cross-sectional area. This strength will be compared to the strength found from the 4-inch diameter specimens. Generally, the strength found for the 6-inch diameter cylinder will be lower than the average strength found from the 4-inch diameter cylinders. The reason for this is that the larger diameter specimen is more likely to contain flaws than the smaller diameter specimens. These flaws allow earlier initiation of cracking in the larger specimen. This phenomenon, known as a size effect, is common in many civil engineering materials, with smaller specimens having higher strength and higher variability than larger specimens.